Let us consider a bar magnet with the north and south. The distance between them, between the poles, is 2L. This is the magnetic axis and this is the center O. Now, there is a point of influence by the magnetic field, that is P. So this is the bar magnet. You've got north pole, south pole, and the distance between these two poles, 2L. O is the center, Sn is the magnetic axis, and along this axis, you have kept a point where the magnetic field of the magnet is influenced here. So this is the x-axis. The pole strength is Qm, that dimension, pole strength Qm, length of the bar magnet 2L, N and S represents the north pole and south pole respectively. R is the distance between the point of influence and the center of the bar magnet. Now there are two influences. This point is influenced by the north pole of the bar magnet and also the south pole of the bar magnet. Now let us, because it has got two types of field, as you know, always from north the magnetic field lines are emerging and received at south pole. So there are two types of influences. The magnetic field due to the north pole, magnetic field due to the south pole. So let us indicate this as a vector BF. This is the magnetic field vector influenced by the south pole on the point P is equal to mu naught divided by 4 pi into Qm divided by, now the distance is from S to P. So you can mention straight away SP square. So it means you have got the distance of the point P from the south pole, that is SP. Similarly, we will indicate NP, that is north pole. Now, you know, if this is 2L and what about this? This is L. And this is also L. So it means this is R plus L. So the distance is R plus L. So what is the distance here? What do you mean by SP here? Which is nothing but R plus L. So this can be replaced by mu naught divided by 4 pi into Qm divided by, instead of SP you can put R plus L whole square. And we have to introduce the I cap, but this I cap is along the negative direction here. So it can be minus I cap. Similarly, let us develop the magnetic field due to the North Pole that is experienced at P is a vector. So mu naught divided by 4 pi into QM, one of the charges. Here, not charges, the magnetic pole strength, QM, divided by, and what is this? NP. Okay, this distance is NP from the North Pole. So NP square, that is equal to mu naught divided by 4 pi into QM divided by R minus, because totally this is R and you have to subtract this. So R minus L the whole square into, it is going in this direction, so I cap along the x-axis. Now we need to add both. So the net magnetic field is, vector is, that is BS, south pole vector, magnetic field due to south pole, plus magnetic field due to north pole, magnetic field vector due to north pole. So that is equal to, now let us add these two equations. So the south pole is mu naught 4 pi into Qm divided by into mu naught divided by 4 pi into Qm. So these are all constants, so you can take outside the bracket. So mu naught divided by 4 pi into Qm. So this is common. And also I cap. Now on adding, and this becomes minus. So you can put first this one, 1 divided by R minus L the whole square. Because of this minus, this becomes minus, and 1 by R plus L the whole square. Next. Now let us take the LCM. So what we are supposed to do? This is R minus L the whole square, and it is R plus L the whole square. So what could be the LCM, which is nothing but R squared minus L squared whole square. Is it not? That is R plus L into R minus L is equal to R squared minus L squared. And this is whole squared. So whole squared means, and this is also whole squared, right? Therefore, B vector net is equal to, you have got mu naught into Qm into I cap 4 divided by 4 pi into, you have the remaining, that is 1 minus, let us take the LCM, so it becomes what? R squared minus L squared whole squared. And you can exchange it, is it not? So it becomes what? R plus L, R plus, expand it, R plus L whole squared minus R minus L the whole squared. So mu naught Qm I cap divided by 4 pi into, let us expand it, R squared, A plus B whole square formula, R squared plus L squared plus 2RL. Then minus, open the bracket, R squared means minus R squared, minus of, again minus L squared, and the minus of minus plus 2RL whole divided by R squared minus L squared whole square. Do not expand always the denominator, okay? It will lead to more complications. So always attack the numerator with expansions. Now r squared can be cancelled. You have 4rl. So mu naught qm I cap divided by 4 pi into what is this? 2rl plus 2rl, 4rl divided by r squared minus l squared whole squared, right? Now, what is the magnetic dipole moment? Qm into 2L. So we can replace this. So let us expand mu naught, then I cap, and then 2R in time splitting this Qm into 2L. So I expanded the, rearrange this. Now you have 4 pi of R squared minus L squared whole squared. So this one becomes M, magnetic dipole. So we can replace with this magnetic dipole moment M. Therefore, mu naught 2R magnetic dipole moment into I cap whole divided by 4 pi R squared minus, what is that? L squared, the whole square. Okay. Now, when R is much greater than L, when R is much greater than L, because we already discussed this, L is the semi-length, and in the case of dipole, magnetic dipole, it is very, very small compared to the R. Therefore, the, I mean, compared to the R, L is much small, so R is much greater than L. So in that case, you can ignore the L so that it becomes net magnetic field vector is equal to mu naught divided by 4 pi, mu naught divided by 4 pi into 2 mr. So you have got here that is 2m and r divided by, okay, divided by what else we have, that is 4 pi into r squared minus l squared whole squared. I said r is much greater than l, therefore l squared is much worse than the original one, therefore r squared, that is l squared, is ignored here, very small. So it becomes r squared whole squared. Okay. So it means mu naught divided by 4 pi into 2m r divided by r power 4. It means mu naught divided by 4 pi into then 2m divided by r cube. Okay. With the I cap. Now this is the net magnetic field under what condition? That is R is much greater than L. Now mu naught is constant, M is constant, 4 pi 2 all are constant. So from this net magnetic field vector is proportional to 1 by r cube. It means that is, let us take the modulus. So net magnetic field magnitude is proportional to 1 by I is released, so 1 by r cube. So it means it is inversely proportional to r cube, the distance cube. So this is a very important relation. This is the derivation of what magnetic field of a bar magnet at an axial point. Axial point means along the magnetic axis, when the point is here along the axis. Now we are going to discuss the same magnetic field when the point lies equatorially. Okay? Okay, so next. Magnetic field on equator of Bohr magnet of Bohr magnet. Now, in this case, we need to consider the perpendicular position of the point to the magnetic field, magnetic axis. So let us consider the Bohr magnet like this. You know, this is the south pole, north pole. So south and north. Now let us consider the distance between them is 2L, and the center of the magnet O, this is the magnetic axis. Now it is equatorially positioned like this. It means it is equally influenced by north pole and south pole. Okay. The point is P. So where we are going to study the magnetic field, and its distance from center of the Bohr magnet is R. Now here the magnetic field due to north pole is influenced like this. This is Bn vector. When it is a magnitude, you can leave the vector. And when it is a repelled, here it is attracted. So it is inward. So this is Bs. Now in this case, you have got the resultant vector in between them. As far as this Bn is concerned, this is the horizontal component. So Bn cos theta. And as far as this one is concerned, this is B S cos theta. Now, if it is R and this is L, 2L, and what about this L and this is also L, and what about the side which is nothing but according to Pythagoras theorem, because this is perpendicular. So, it's a right angle. Let us consider OPN, O at the right angle. So, this is R squared plus L squared. So, the whole square root of L squared plus R squared. Take down. Now, let us proceed with the determination of magnetic field due to North Pole. And I'm going to consider only the magnitude. So let me put, I'm not introducing any vector here. So Bm is equal to mu naught divided by 4 pi into Qm divided by, and what about this one? This is P, this is N. So the distance is Pn. So Pn squared, right? Okay. So this is along Np or Pn. Therefore, Bn, magnetic field due to north pole, is given by mu naught divided by 4 pi into Qm divided by, we know already this Pn is nothing but square root of L squared plus R squared. Therefore, Pn squared means simply L squared plus R squared. So you can put L squared plus R squared, right? Next. So this is along NP. And then along PS, that is BS, magnetic field due to what? South pole, is given by mu naught divided by 4 pi into Qm divided by. Now we had to consider this. So this is also L squared only. So this is PS squared, right? PS squared. So it means Bs is equal to mu naught divided by 4 pi into Qm divided by. So Ps is nothing but L squared plus R squared. Ps squared is equal to L squared plus R squared. Both are same. So L squared plus R squared, right? Because this is also L squared plus R squared only. What is this? This Ps. Now from this it's clear that Bn is equal to Bs, right? Both are same. Okay, because it is in the equatorial position. So as far as magnitude is concerned, this one. But we need to prove the vector as vector. So in that case, now let us consider the vertical component. Okay, let us consider the vertical components of Bn and Bs. They are equal but opposite to each other. So they cancel out. Okay. So it means B vector net, let us consider the modulus, that is equal to Bn cos theta plus Bs cos theta, that is equal to 2 mu naught, because this one is mu naught, this is also mu naught, same quantity. So you can put twice. That is why I put 2 mu naught, right? Divided by 4 pi into Qm divided by L squared plus R squared whole L squared plus R squared. And here we have got the cos theta also. So this is cos theta, 2 cos theta. So what is cos theta here? Let us consider this is the theta. Okay. So cos theta means what? L by what is that? This one. L squared plus R squared. Is it not? So cos theta is equal to L divided by the square root of L squared plus R squared whole squared. I'm sorry, L squared plus R squared square root. And this can be written as L by L squared plus R squared whole power 1 by 2. So this is cos theta. Okay. Now we can replace this cos theta by this unit value. Therefore, B net is equal to 2 mu naught divided by 4 pi into Qm divided by L squared plus R squared, L squared plus R squared, and then into what is that? Cos theta. That is L divided by L squared plus R squared whole power 1 by 2. We know A power 1 by 2 into A power 1. A power 1 and half. 1 plus half. That is A power 3 by 2. Right? So this becomes 2 mu naught divided by 4 pi Q m L divided by L squared plus R squared whole power 3 by 2. Okay? Because we know A power m into A power m is equal to A power m plus a. Now we know this Qm into 2L is equal to what? P. That is m here. So m is equal to Qm into 2L, which is nothing but magnetic dipole moment. Yeah. Therefore, B net is equal to mu naught into m divided by 4 pi into L squared plus R squared whole power 3 by 2. Okay. So this is the what? The net, the magnitude of the, you can, otherwise you can put like this also. Either free of vector or modulus of vector or magnitude only. Now the direction of the B is anti-parallel. Okay. Take that. So true, we can't measure the relation. Okay. We cannot. We can proceed. That comes as a, that is case only. We can do that. Now, and I was talking about the anti-parallel concept. Okay, take the direction of B. The direction of B is anti-parallel. It means theta is equal to 180 because it is in the opposite direction. Is it no? To the magnetic moment. Moment. Now we can consider a case when R is much greater than L. So L is neglected. So B vector net is equal to mu naught m divided by 4 pi into, and here what is neglected? That is L is neglected. So R squared whole power 3 by 2. So in that case it becomes R cube. Therefore the modulus of magnetic field is equal to mu naught m divided by 4 pi R cube. Again B is proportional to 1 by R cube only, being mu naught m 4 pi constant. Okay. Now we are going to show that the solenoid is equivalent to a Bohr magnet. So this is another important concept. Solenoid. Solenoid is equivalent to Bohr magnet. The Bohr magnet. Solenoid equal to the Bohr magnet. What do you mean by solenoid? The coil wound on the iron core in a cylindrical fashion like this, okay, with equidistance. And it can be simply represented by a cylinder like this, assuming that you've got a lot of coils. So this is a solenoid. Okay, and this is the center. This is the axis of the solenoid. Let us consider a point P that is influenced by the solenoid, that influences the point solenoid, that is kept at a distance r. And since it is along x-axis, let us consider a small length element of dx width, and the radius here is a. So L is the 2L is the length of the solenoid. Therefore, half of this is L. Now let us apply the same logic here. Magnetic field lines of a bar magnet and solenoid almost show similar patterns. Now let us calculate the magnetic field, that is axial field. We are focusing on the axial field of solenoid. Let me say this contains n number of turns of coil, this solenoid, per unit length. A is the radius of the solenoid. A, that is the radius of the solenoid coil. Now each turn of solenoid is at a different distance from the fixed point P. Is it not? So let us consider the circular element of thickness dx. So circular element of the solenoid of thickness dx. That is this one. So likewise it has many number of turns. Dx of the solenoid at a distance x. At a distance x. That is, um, let us consider this is the center. From this is the x at a distance x. So the distance of the circular element from the center of the solenoid. What is x? The distance of the, what is that? Circular element of the solenoid from the center. And what is dx? That is the circular element of thickness. That is thickness is dx. Okay. So that particular thickness, that is at a distance x. Now let us assume there are n turns. Therefore, number of turns in element is equal to n into dx, because dx is the, I mean is the number of turns of coil per unit length. Okay, for if it is for per unit length and if it has a dx, so this is the number of turns in dx, that is n into dx. Now we are going to study the magnetic field produced by these small terms. So it is differentially small, so we can put the small differential element of magnetic field dB. So this dB is given as 2 mu naught, 2 mu naught, and it is based on the current. So I, when the current is more, you know very well, the magnetic field is also more. Then it is also proportional to the square of the radius, so you can put a square, and you got pi here, pi value, pi a square, because it depends on the area. So we can put area that is enveloped by the coil or the solenoid. So pi a square, let us put pi a square, and n number of turns of element. So n into dx divided by 4 pi into r. So here it is r minus x whole square plus, what is r minus x whole square here? R minus x means this is r minus x. So it indicates that the distance between the P and the circular element. So r minus x. So this distance is r minus x. Do you understand? This is r and this is r minus x. And that is why we have put r minus x. So the r minus x, the whole square, that is nothing but the r squared plus a squared. A squared means we already got that formula, for axial field, we have got r squared plus a squared. So instead of r, we can put r minus x the whole square, because we are discussing about a particular element dx. So that is kept at a distance r minus x here plus a squared and a whole power 3 by 2. So this is the equation for dB. Now we are going to differentiate this. Down. So differentiation of, integration of dB is equal to dB is equal to 2 mu naught, then n and I, then pi a squared, then dx, whole divided by 4 pi. So 4 pi into r minus x squared the whole square into r minus x the whole square. So r minus x the whole square plus a square whole power 3 by 2. Now we need to integrate this. Take down. So let me repeat. Let me write down the constants first. So 2 mu naught I pi a squared n whole divided by, and here you have 4 pi. Is it not? So 4 pi, and then you have this r squared. Okay, that involves the x. So you have to include that one into, now dx divided by r minus x the whole squared plus a squared whole power 3 by 2. You have to integrate here. These are all constants. Okay. Now this pi a squared is nothing but, no. Pi a squared is nothing but area, okay, enveloped by the coil. Is it not? Or area of the cross section of the solenoid. So pi a squared can be replaced by a, capital A. That is the area enclosed by the coil. by the coil in solenoid. Then you've got I, and you have what else? Okay, that's all. So let us replace all these things, that is equal to, and moreover, let us consider, that is R is, and actually this is between, we need to consider the total length here, because this is to be integrated from here to here. So you can call it minus L, and this is plus L. Okay. So from minus L to plus L, you have to integrate it down. So from minus L to plus L, we are integrating. Now 2 mu naught A I. Okay. 2 mu naught A I into small n divided by 4 pi into integral between the limits. This becomes B. So minus L to plus L. Okay, take down minus L to plus L. Now let us work out this. We are considering R is much greater than L. Take down. R is much greater than L. What do you mean by this? That is, we had to consider R means the distance between the point P and the relevant dx element. So, and here the center of the coil. So this is R. And L is the semi-length. What is that? Semi-length of the solenoid. So when we consider R means, that is the P is at a larger distance. So we take such a case. So R is much greater than L. This is one point. Second point, when you consider the radius of the circular coil in the, what do you call, solenoid, compared to the R, A is also less. Okay. So there are two cases. R is much greater than L, and R is also much greater than A. Okay. So in that case, you can neglect L and A. Okay. Now let us proceed. So here dx divided by, and I neglected what, that is L and A. So let us consider this one A. Okay. So the A is cancelled here, and the X, you know, X is also very, very small. Okay. That is the distance of the, what, the particular element from, yeah, center. So in that case, R squared, and then whole power 3 by 2. Okay. Do it carefully. So 2 mu naught, don't strike out anything now. AI and N divided by 4 pi into, this is R cube. Is it not square cancel? R cube. You can take outside the bracket integral R cube. Now it becomes minus L plus L of dA. Take down. Okay. Next, what we are supposed to do, that is equal to integral of dx is equal to x. So if it is between the limits dx minus L plus L, it means x between the limits minus L plus L. It means final minus initial. Okay. So L minus of minus plus L. So that becomes 2L. Okay. Right. So this value becomes what? 2 mu naught A in and then into 2L divided by what? 4 pi r cube. Okay, 4 pi r cube. Now this n into L, n into L, that becomes the length. I mean the net number of turns, capital N. Okay, so overall, so you can mention this point also. We have got n. This is the number of turns per length. Okay, what is this? N is equal to number of turns per unit length. Now I am multiplying this unit length by the overall length L, that is 2L, that is the overall length, is it not? So that becomes what? That is capital L. So don't forget, total number of turns of solenoid. So that is equal to, you can strike out this one now. So mu naught A I capital N divided by 2 pi r cube is equal to B. Okay. So mu naught by 2 pi. Okay, mu naught by 2 pi. In fact, that is, let us not strike out because uh, we want to retain that mu naught by 4 pi as constant. So let me take this as 4 pi and this is 2 as such. Okay, so it becomes 4 pi mu naught by 4 pi into 2 into a into I into n. Okay, have I kept this 2 here. So let me rearrange. B is equal to, let us write mu naught by 4 pi separately, and then 2 mu naught, 2 NIA, 2 NIA, got it? NIA into 2 divided by, and you can write R cube separately. Okay. Now, here M is the magnetic moment that is equal to NIA. Take down. This is a very important relation. M is equal to N into I into A. So you can further replace this. Okay. M is equal to NIA. Therefore, B is equal to mu naught by 4 pi into, what is that? NIA is M. So 2M, right? Divided by R cube. Okay. Divided by R cube. Yes. So magnetic dipole momentum. So that is also in terms of what? NIA for solenoid. Okay. Because it depends on the current in this case. So this is also the same expression for magnetic field due to Bohr magnet that you can find out. Okay. Now we want to maintain this as a constant, mu 0 by 4 pi as a constant. Okay. So that you need not. You have got already 2m divided by r cube. And we will finally show that B is proportional to what? When m is constant, you can put 1 by r. When m is constant. How m constant? Fixed number of turns. I, fixed current. A, area cross section of the solenoid, or area enveloped by the coil in the solenoid. Okay. So we are able to get the same relation in the case of Bohr magnet. So that is why the solenoid acts like a Bohr magnet. So likewise here. Okay, they will simply ask this question. So that the solenoid magnetic field due to the solenoid is equal to the magnetic field due to Bohr magnet. Okay.